Thank you very much for joining me today for my presentation, Situational Awareness in a Technology Ecosystem. I'm really pleased to have you and really pleased that you've made that decision to sit in and spend some time with me. My name is Charles Boicey. I am the Chief Innovation Officer of Clearsense. Clearsense is a healthcare data platform that you'll learn a little bit about, as well as I'm a clinical professor at Stony Brook University. I developed out their applied health informatics electives, and I still teach there. So I'm coming to you both from a clinical perspective and then from an academic perspective as well. So let's talk about the clinical perspective. Remember, we're talking about situational awareness. So this is actually a shot from the environment that I basically grew up in. This is the trauma unit at LA County USC Medical Center. If you really want to get and take a look at it a little bit more in detail, there's a good documentary out there, Code Black, and as you know, it became a series. So where I'm coming from here is that look how chaotic this environment is. There's a lot going on, but does any individual, truly know what is going on from a, perspective of, what we're going to do next? The answer is yes, absolutely. We have all kinds of instrumentation on these patients, and as a result of that feedback, from that instrumentation, we then go forward. So this is very much a talk about taking what I've learned from the healthcare environment and then applying it, yes, to a healthcare data ecosystem, but also applying it to any kind of environment out there so that we have, situational awareness on our technology. So let's get into it. So situational awareness, really, what is that? So situation awareness, let's talk a little bit about what it helps us do. If we're paying attention and we're doing this properly, we have enough information to make really good decisions now so that we're not, running around with our heads cut off, our hair on fire and whatnot, taking care of problems after they occur. So in the healthcare environment, it's knowing a little bit about the past, most recent past, knowing a little bit about what's going on now, and then what's likely to occur. So think about, our environments, our technical environments. The more we know about past operations, the more we know about what's going on at the present time, and the better we can then make, decisions, going forward. And if you think about what we do, a lot of it is really, really reactionary. And we really want to get away from that. So the utilization of both instrumentation, technology, and humans, we can do very well. Matter of fact, we've done exceptionally well in healthcare by helping clinicians understand what's likely to occur, especially with patients that are critically ill, what's likely to happen in the next 30, 60, 90 minutes in forward. So that's really situational awareness, very much used by our military, and then other disciplines out there use situational awareness as well. So why can't we, from a technical, environmental regards, use situational awareness? The answer is we absolutely can. And here's an example of it. So this is visualization of instrumentation on patients that is allowing clinicians to, better understand the patient at any particular point in time, but also give recommendations or make them aware of whether the patient is likely to have an issue in the near future, or even a little bit further out than that. And in this case, if we take a look at this, their likelihood of coding, coding is where your heart stops, and we have to give you a bunch of drugs, potential electrical stimulus, but in pump on your chest and so forth to get you back. Sepsis, this patient, looking at these lab results right now, is of a high likelihood of entering a sepsis pathway. So think about that when you think about your environment. What are some of the things that we can monitor in real time that allow us to um, have a good take on what's going on now and what's likely to happen in the near future? And then we're going to talk a little bit later about actually putting this into practice. And more importantly, just think about your dev team, your data team, your data science team. If they know that these technologies exist, these observability technologies exist, then they can develop, they can build models, they can do what they need to do, knowing that we can interject observability into the process, so that at the end of the day we have a really good understanding of what's going on at any particular time. So let's go further. So I wanted to give you a little bit about healthcare from an environmental perspective, from a technology perspective, because it's extremely complex. If you think about it, there's financial aspects. Yes, there's healthcare aspects, but there's also, logistics aspects to this. There's supply chain aspects to this. There's actually environmental aspects to this. So if you think about health, your health is not just influenced on the time you spend with us in a clinical environment, but it's also about what you experience, outside of our care in the current in your environment. So social determinants of health. We do a lot with streaming data. Think of all those instruments. Think about the wearables at home and whatnot, streaming data and so forth. Provider data, exposome data. What's that? Exposome data is about data about the environment, temperature, pollen counts, humidity. Are there grocery stores in the area? What's the crime rate? And so forth. Imaging data, X-rays, and other modalities. Genomic data, matching that omic data up with the phenotypical data, and of course electronic medical record, claims, research, and so forth, and many, many more. This is just an example. So if you think about the complexity of the healthcare data environment, it's as complex as the patient's physiology. And that's again why I thought, take what I've learned from a healthcare perspective and bring that into the technology environment. So what's a modern data architecture for healthcare look like? We're going into the multi-cloud environment where we have our private cloud. We have the three big hyperscalers and so forth. But at the very base level, hyperconverged on composable. What the heck is that? Well, from a composable infrastructure, the ability to scale out compute memory as needed, storage in all different types, whether it's SSD, whether it's spinning disk, and so forth, in memory. And then, the data lake or hyperconverged. So, VM, Nutanix, those kinds of technologies, and think of the complexity there. And then that, data lake on top of that. And then from a translytic environment, we've got, data pipelining from ingestion all the way through consumption. We'll talk a little bit about that, data discovery, of course, data governance within that, whole thing. And then on top of that, we've got all kinds of applications, whether they've been created by ourselves, they've been created by vendors, and so forth. So very, very complex, and you can imagine with this type of complexity, you may not have this type of complexity. Maybe it's a little bit more, but you still need to be able to, have really good awareness on this environment and really understand, historically what's gone on, what's going on now, what's likely to occur in the future, so that you can keep your uptime as high as possible. You can only imagine what my contracts look like with my healthcare providers, especially those that rely on applications and data from a system like this, that they're actually treating patients. So just think about how many nines to the right that looks like. And again, emphasizes the real need for situational awareness. So again, let's take a look at this a little bit more of a deep dive. So think about the various data sources that we're going to need to monitoring. Those can be, streaming data sources. So data from the home, physiological monitors, ventilators, and so forth. And think about, other data from a scientific perspective, research. You've got omic data, you've got images, you've got all different kinds of, scientific data. And then think about the, social determinants of health, even data from social media. A lot of that is extremely important. And then, your electronic health record, your lab systems, your radiology systems, and so forth. From a consumption or from an ingestion perspective, think about all the different, points, in there, whether it be API, whether it come through a VPN tunnel or FTP tunnel. Think about the various areas of observability that are required to ensure that those processes go on smoothly. Because if you think about it, if I'm streaming data from physiological monitors and so forth, I need that to be uninterrupted. So from an observability perspective, I need to ensure that the technologies are in place to observe that streaming data, as well as from a Lambda perspective, that data that comes across in a batch process. And then if we think even get into a little bit further, when we get into the the transformation processes and so forth, just think about in healthcare we do all types of attribution, we do all types of ontological right sizing. So within that data pipeline, within that transformation process, we have all kinds of RPA technologies in place. Those all have to be monitored and observed, because again, the end output, somebody is going to actually deliver care based on that. So you have to have monitoring in place for that. And then as we go again from a transformation prospect, from raw to curated to enriched, everything in between, data going from brought in, raw, combined, all of that. And then at the very end point, you've got data science workbenches, you've got all types of applications, you've got all types of users within the healthcare environment. They can be clinicians, they can be operational people, they can be research folks, as well as financial folks. So think of this ecosystem, all the various things that are going on in this ecosystem, the constituents that are using it, and the absolute importance that we have good observability, good insights into this environment, so that we can ensure that we have maximum uptime, maximum efficiency, and so forth. I'm not going to get into the security aspects, but just so that you're aware, these environments are high trust, SOC 2, ISOs, HIPAA, PCI, PHI, etc. So from a security compliance perspective, all of these observability points are within the environment as well. We're just not going to concentrate on them as much in this discussion. So, really, what do I mean here? So in our environment, we have human beings. We have human beings 24/7 monitoring this environment, but not as you think, not where they're sitting and looking at multiple screens and so forth. They're actually being assisted by technology. So if you think about a couple cases in point, let's say that we are bringing in streaming data and there seems to be some slowness. So the machine learning, the observability components are letting the humans know that something has started that's a little bit different than it has in the past. Something's going on, situational awareness, that humans can now interact with the environment, understand what's taking place, fix it, and then kind of move on. But more importantly, from a performance perspective, are the volumes increasing and so forth, and we get that information. So other parts of this, from an observability perspective, I'll get into in a second, but it's really important that and this is me, this is my environment. Human beings need to interact with the machines. The machines let us know what's going on, what's likely to occur, recommendations, and so forth. Also, from a planning perspective, which we'll get into in a bit. But anyhow, it's not just humans; it's technology. I don't like to use the term artificial intelligence. I like to use the term intelligent assist, which it is. The humans here are still in control, with the exception of a couple things. We're going to get into that in a bit. But okay, so observability, so we have private cloud environments. Our clients also call their on-prem their own private cloud, and we have multi-cloud. So we have Azure, AWS, GCP, public data sources. We are no longer in an environment where we're making choices. Hey, I'm just going to go to Azure. I'm moving off my, my private cloud. I'm going into Azure. In my organization, I'm in all of them. Why, do you ask? And why are we moving that way? Because I may have data stored in all three, all four. There may be applications within the Azure environment, or I may have clients, and I do, that are in love with Google BigQuery. So I'm going to have certain workloads occur in GCP. I need awareness of that. I need awareness of what I have running in AWS, and I bring in all kinds of public data, data sources from S2 buckets and so forth. I need some awareness on that as well. So from an observability perspective, we can't just think about it as an individual. We got to think about it in this multi-cloud, kind of a concept, if you will, and it is practical. So the tools that we use, we got to ensure that we can, take care of this. And again, we don't want to, a whole bunch of, panes of glass, if you will. We want a single environment that humans can interact in. It's really important. Machines can handle, multiple panes of glass, no problem. But humans get a little confused and a little bit, weary with, more than one environment to work in. Let's talk a little bit about focused observability. I talked a little bit about it before. You think about the different, data ingestion. I talked about, Lambda architecture, where we've got streaming data, we've got batch data of all types, and this is 24/7. Streaming data is 24/7. It never stops. And again, just think about instruments, at the edge, bringing in data. And this applies to whatever the vertical might be. You need to be able to understand that, monitor it, and so forth. Think about the data processing, and we talked a little bit about that. All the different RPA components, regardless of your industry, there are RPA components within the data processing pipeline. You need to know how well they're doing, if there's been any changes. Data consumption from a consumer perspective. Really important that we understand the consumption patterns and so forth. There's some cost, performance, customer satisfaction that goes along with this. And then from an ML AI model perspective, how well are my models performing? What's the drift look like? And are people paying attention to this? Are they actually taking action from these ML AI models and so forth? In our environments, we do a lot of data science experiments, right? Prior to model deployment, we're doing experiments. Data scientists sometimes do weird things. We need to be able to, monitor that. And then from a data engineering perspective, and then from a ETL, ELT, and the whole pipelining, sometimes humans do weird things and build out, weird pipelines. And sometimes the models aren't quite as efficient as you'd like them to be. So it's really important that we have, observability in that environment, in that respect. So in practice, rogue queries, shut them down. AI, ML, shut them down. So we have put, practices in place that if, one of our clients, data scientists, or one of ours, or anybody puts some kind of whacked out query in there, it will shut it down before it starts consuming, resources and whatnot. And then we get a nice report. And of course, somebody's going to be on the phone screaming and yelling anyhow. We can then do that interaction, let them know why, and so forth. The data ingestion needs to be monitored and regulated. We're expecting, X, gigabytes. It looks like, from a ingestion perspective, what's planned on being brought in is 70 terabytes. Let's shut that down and, better understand what's going on. Data pipeline, again, I talked about, code not being quite right. It's important that that's monitored and regulated. It's important that each step of that data processing pipeline, as the handoffs are made, are monitored, and we know what's going on. Consumption, I talked about that a little bit. And again, humans are made aware of these trends early on so that action can be taken. And this allows us to go from, reactionary practice to a proactive practice. And this really is situational awareness, within our data environment, within our infrastructure environment, and within our multi-cloud, environment. So what are some of the changes in practice? And this is really why it's really important that everybody on the teams are aware of what we have in our toolkit, if you will, from an observability perspective, so that as the data scientists are building out their models, as our data engineers are building out their data pipelines, as our consumers are interacting, they know that there's technology that we're able to build into our practice. So what does this allow us to do? So as a data engineer, as I'm building my code, I'm working with the infrastructure team, and we're collaborating on where we're going to place those points from an observability perspective, so that that can be monitored, again, by machines that are then going to allow us to, tell the humans, how things are going. And then we get all kinds of good data on how efficient things are, what is the cost optimization, which is really, really important. So before we go out and, make some, really bold, statements as far as cost to clients and whatnot, we really understand that. When we run these, various pipelines and whatnot, oh my gosh, that one's taken a heck of a lot of memory. It's taken a lot of compute resources, all of that. That's super going to be super expensive to run that. Have we costed out properly for the clients? Also, placing the proper workloads in the proper environments. This goes a long way for that as well. And again, if we understand the technologies as we're developing out, we can optimize before we have any issues. And then from operational research within our own environments, this goes a long way to ensure, again, that we're optimizing. Again, so the goal here is so that we change practice, so that as we change practices, we become more efficient, and we have less issues. And it really is true from a less issue perspective. Again, I have clients that I'm allowed unscheduled downtime of about 4 to 5 minutes a month. So you can imagine, the observation points that I have in place to ensure that. And more importantly, I've got clinicians that are, relying on my environment to practice. Before we adjourn, I really wanted to kind of go over what this is going to look like at the edge. So not only observability within our environment, we're going to push observability out, to the edge. This is one, project in particular where we're doing this. This is the Institute of Health at the University of California at Irvine. The project there is called Personical, and our hypotheses is health is not just the absence of disease. We currently are not providing healthcare. We're basically providing sick care. You come see us when you're sick. You don't come see us because you're healthy. We want to flip that. And the only way to really flip that is to have all of the citizens of the globe, if you will. Yeah, we're going after the globe. Be involved in their own health. Understand what makes them healthy. So if you think about it, some point in the future, you'll come see us if you've had some type of traumatic injury, viral or bacterial infection, and then you're genetically predisposed. So having that, observability at the endpoint is really important, because if you're scaling into the millions and eventually, there's billions of plus, folks on this planet, really important. So not going to get into it all that much, but think about the collection of data at the edge, everything that you're seeing from a food intake, of course, heart rate, blood pressure, mood, mental status, all of that. We talked about some other data sources and whatnot, but all of that combined to then, push out recommendations to you during the day so that you lead a healthy life. Think about the observability points that are going to be really important in that, so that we're able to monitor this, not just at the infrastructure level, but at the application level. Extremely, extremely important. Again, dashboard of Personical, and again, all of the various data points and all the stuff that's going on in the background. It's really, really important that it's well understood and monitored, so that if there are issues, they can be taken care of, well in advance before they actually impact, human beings. So all kinds of data streaming that needs to be observed, all kinds of events, all kinds of AI, ML, and then push back out, to the patient. That's it. That's my talk. In summation, we all have very, very complex environments. We now understand what situational awareness is. Knowing a little bit about what's gone on, knowing a little bit about what's going on now, and more importantly, to be able to predict what's likely to occur in the near future. How does that help us? It helps us be proactive and not reactive. And I'll kind of leave it at that. Anytime you want to reach out to me, by all means, please do so. You can either connect with me at Clearsense, or by all means, please contact me at Stony Brook. With that, I am going to say goodbye and enjoy the rest of the conference.